Good morning. Today we are starting Chapter 7. We are solving linear systems of equations. Systems meaning that there are more than one line or more than one equation. And we need to figure out where those two lines or those two equations would cross if we were to graph them. So it says linear systems consist of two or more linear equations. So two equations or two lines. And then the solution or the answer to our problem that we're going to solve here, a solution to a system of equations is an ordered pair. So x comma y. That ordered pair is going to be our answer that satisfies each equation, or it works in both equations. It says one way to find the solution is by graphing. The solution is the intersection of the lines, or where they cross. So if we have our x and our y axes, oops, that was not good. Let's try that again. If we have our y and our x axis there, and we graph two lines, let's say this line looks like this, and the other line looks like this. That point right here where they cross, like 2, 1, would be our answer to the linear system. So we're going to have to figure out, without graphing these ones, tell whether the ordered pair is a solution of the system, yes or no. So we need to take x and y and plug it into this equation and this equation. If it works in both, yes, that's where they cross. If it does not work, that means it might be on one line and might not be on the other. So for our example back here, this one, yes, if we plugged in the point 2, 1, it would work in both equations. But if we plugged in this point here, well, yes, it would work for the red line, but no, it would not work for the blue line. So that's not going to be our answer. So that's what they're asking us to do right here. So let's take x and y and plug them in. So I'm going to call this line A. We're going to try line A first. So it says 2 times x, and x is 5, minus 3 times y, and y is 2, equals 4. Well, 2 times 5 is 10, minus 3 times 2, which is 6. Well, yep, 10 minus 6 equals 4. So yes, this one works. But we need to test line B as well. So it says 2 times x, which is 5, plus 8 times y, and y is 2. We need to see if that equals 11. So 2 times 5 is 10. 8 times 2 is 16. Is that going to equal 11? Well, no, that's not going to work. Excuse me. So overall, our answer would be no, it is not a solution because it's on one line, but not on the other. So let's try our second point. This is x and y. I'm going to call this line A again and test that first point. So x, which is just -3, plus y, which is 1. Does that equal -2? Well, -3 plus 1, there's more negatives, there's 2 more. It does equal -2, so this first one would be yes, it works. But the second one, B, let's test that one. X is -3, plus 5 times y, which is 1. Does that equal a +2? Well, order of operations tells me to multiply first. 5 times 1 is just 5. So -3 plus 5, there are more positives, and that one also works. So if they both work, that means that that point is on both lines. That's where they're actually going to cross. So the answer would be yes, that's a solution. So that's what we looked at right here. Check the intersection. Wherever our two lines are crossing, that's going to be our solution. So it says use the graph to solve the system. Then check your solution algebraically. So our solution is this point, 1, 2, 3, x, y. Remember, x is to the right first. 3, and then we go up 1, 2. So our point is 3, 2. That's our solution or our answer. They want us to check it in our equations to make sure that it works. So we're going to plug in these numbers for x and y. So in this first one, x is 3, plus 2 times y, which is 2. You need to see, does that equal 7? Well, order of operations tells me to multiply first. 3 plus 4 is 7. That one works. And then we need to test the second equation as well. 3 times x, which is 3, minus 2 times y, and y is 2, and to see if that equals 5. Order of operations again tells me to multiply first. 3 times 3 is 9. 2 times 2 is 4. Yep, 9 minus 4 gives us 5. So they both work, so we know, yes, this is a correct answer. That's where their two lines cross. And we just proved that algebraically or using algebra math. So now we need to figure out the solution to a system of equations. Solve the system by graphing, and then check your solution. So in order to graph, we need to solve these equations for the letter y, because we need y by itself to graph. Y equals mx plus b. So in order to solve this one, or graph this one, I'm going to subtract 3x. So I have y equals negative 3x plus 7, because we write our x's first. So that one's ready to graph. And then we're going to solve the other one as well. Same thing here, I want y by myself, so I'm going to add 2x on both sides. So I have y equals 2x minus 8, and that is also now ready to graph. So I'm going to start by graphing this one in the form y equals mx plus b, because we have y by itself. So here's y, here's x. So we're going to begin our graph at 7. So up 1, 2, 3, 4, 5, 6, 7 on our y-axis or our y-intercept. And our slope m is negative 3, or as a fraction, negative 3 over 1. So down 1, 2, 3, and 1 to the right. Down 1, 2, 3, 1 to the right. Down 1, 2, 3, 1 to the right, over and over again. Or up 3, 1 to the left, and draw your line through. Now that we have that graphed, we're going to graph our second line. It's also in the form y equals mx plus b. So we're going to begin not at 8, but at negative 8. So down 1, 2, 3, 4, 5, 6, 7, 8. And our slope is 2, or rise over run 2 over 1. Rise 2, 1 to the right, up 2, 1 to the right. As you can see right there, that point is going to be on both lines. Up 2, 1 to the right. Or down 2, 1 to the left. And our points or our lines should cross at a very nice point that we can see x comma y. So right here is where they cross. So on my x-axis first, 1, 2, 3 to the right. And then y, we're going down negative 1, negative 2. So 3, negative 2. That is our solution. We could check our solution by plugging in an x here, a 3 for x, and then a negative 2 for y, and make sure that it works out, or the answers are equal to each other for both equations. Let's try another one. We need to solve these both for y before we can graph them. So first I'm going to add my 3x over to the other side. So those eliminate. We have y equals 3x plus 0, or just 3x. If you want to graph that one right away, we can. It's in the form y equals mx plus b. b is just 0. So we're beginning at 0. And our slope is 3 over 1. Or rise 3, 1 to the right, up 3, 1 to the right. You can always check to see if your slope is the right direction, positive slope, walking across uphill from left to right. Or down 3, 1 to the left. So there's that one. And then I'm going to solve this other one so that we can graph it as well. We want y by itself, so move your x's first. I'm going to add 14x. So those eliminate. eliminate, we have 2y equals 14x minus 8. And we want to get y by itself, so I'm going to divide everything by 2. Because that's multiplied, we need it to divide. So those eliminate, we have y equals now 7x, and negative 8 divided by 2 is a negative 4. So that's in the form y equals mx plus b. So we're beginning at negative 4. So down 1, 2, 3, 4. And our slope is 7, or 7 over 1. So I'm going to go up 7, 1, 2, 3, 4, 5, 6, 7 over 1, right there. Up 1, 2, 3, 4, 5, 6, 7 over 1. Or down 7, 1, 2, 3, 4, 5, 6. Oh, 7 would be 1 off the graph, but if you want to put it there, you can. Those lines are very close together, but you can see as you are graphing that this point right here is where they cross because you put 2 points there, one from the blue line and one from the red line. So that point, x comma y, x is just 1 to the right, and y is up 1, 2, 3. So our answer is 1, 3. And if we wanted to, we could plug it back into our equation, either the original equation or the one that we solved for y. All right, I would like for you to try this one on your own and then check to see if you got it right. So this one's solving for y. All we have to do is add x. If you want to put a 1 there for the 1x, you can. So we have y equals 1x. If you want to put plus 0, you can, because then it technically is in the form y equals mx plus b. But we don't need the 0. It just helps us to know where to start graphing. And the second one, we need to get y by itself again, so add 8x, get rid of the x's. So we have 2y equals 8x minus 18. And then there's that 2, so we need to divide everything by 2. So we get y equals, well, 8 divided by 2 is 4, so 4x, minus 18 divided by 2, which is 9. So here we have our 2 equations to graph. I'm going to graph this one that's in blue here first. So we're beginning at b is 0, and our slope is 1, or as a fraction, 1 over 1. So 1 up, 1 to right. Remember way back in chapter 4 we called this our parent function that we compared other graphs to. Up 1 and 1 to the right, or down 1, 1 to the left, down and left, down and left. So I'm going to draw my line through that one. And then also we need to graph our second line here. In the form y equals mx plus b, we're beginning at negative 9. This graph goes to 10, so I know negative 9 is 1 away from the bottom. And then my slope is 4, or 4 over 1. Rise 4, 1, 2, 3, 4, and over 1. Up 1, 2, 3, 4, and over 1. Up 1, 2, 3, 4, over 1. Oh, there you can tell that's where we're going to cross. Up 1, 2, 3, 4, over 1. And I'm going to draw my line through. So that point right there, our answer, x comma y, we're going 1, 2, 3 to the right, and then up 1, 2, 3. 3 comma 3 is our answer. Again, if you want to plug it in to make sure it works, you can. So now we have a multi-step problem. It says a business rents inline skates and bicycles. During one day, the business has a total of 25 rentals and collects $450 for the rentals. Find the number of pairs of skates rented and the number of bicycles rented. So in all of these problems we've solved so far, we've had 2 equations. So if we look at this information, we're going to have 2 pieces of information, or 2 equations, one that's based on the number of rentals and one that's based on money. Okay, and they give us some more information over here. The skates, or rollerblades, cost $15 per day, and the bicycles cost $30 per day. We're also going to need some letters here, so I'm just going to say X is going to represent skates and Y is going to represent bicycles. So right down here, X is going to be skates and Y is going to be bicycles. So we know that there are going to be a total of 25 rentals in that one day. And those rentals could be made up of skates and bicycles. So our first equation is just simply going to be the number of skates plus the number of bicycles has to equal 25. Just the skates and the bicycles right there, they told us had to be 25. Well, they also gave us another equation that has to equal 450. And this is talking about money. Well, we know that the skates cost $15 per day, but we don't know how many there are. So I'm going to say 15 times the number of skates that we rent. And we don't know what that is. We used the letter X to represent that, though, so it's 15X. Plus the cost for the bicycles, which is $30, times the number of bicycles, Y. So now we have two equations, let me erase this for a second, that we can use to graph. And wherever those two equations cross is where our answer will be. So I'm going to take this equation and I'm actually going to move it over here. I should have done that previous. So that we can solve both of these. If you just want to rewrite one, that's fine. So let's solve both of these equations. Doesn't matter which one we do first. I like this one. It's just easier to solve. I'm just going to subtract X. So I have Y equals negative X plus 25, or negative 1X plus 25. So there's my first equation. And then my second equation, I also need to solve for Y. So I'm going to move my 15X over, subtract 15X. So I'm left with 30Y equals, and then we have the negative 15X plus 450. And then we need to divide by 30. So those eliminate. We have Y equals, and this is going to be a negative, 15 over 30. We can divide both of these by 15 to give us 1/2, or 1 over 2. And then 450 divided by 30. You could think 45 divided by 3, but if you type that in your calculator, 450 divided by 30, you should get a nice 15. So let's graph both of these. This one starts at 25 and this one starts at 15, so I need my y-axis to at least go by 5s, let's say, because we need to get up to 25, so I'm just going to go by 5s. 5, 10, 15, 20, 25, 30, 35, that's plenty. And then the same thing on this axis. I'm going to go over by 5s, 5, 10, 15, 20, 25, 30, 35. So again, X is skates and Y is bikes. But we need to graph these. So I'm first going to graph this one in blue. So we're going to begin at 25 right here. And our slope is negative 1 over 1. This seems like a lot of work if you literally went down to 24 and over 1, down to 23 and over 1. That would be a little crazy. You guys, if we go down 5 and over 5, so like down one whole thing here, down 5 over 5 to here, isn't that the same as going down 1 over 1 if we simplify? So we can actually do that looking at the grid lines to go down 1 over 1, down 1 over 1. Because it's just the same, we're just doing 5 at a time instead of going 1, 2, 3, 4, 5, down 1 over 1. We could have all those little tiny lines in there, but we don't need to. We can just go down 5 over 5 at one time. It'll make your life just a little bit easier because this is just simplified to 1 over 1. Same thing here, we can start this graph at 15, and we're going down 1 over 2. Well, that's the same as going down 5 and over 10, because if we wanted to divide this by 5, that's the same as down 1 over 2. So we can really go down 5 and over 5, 10. Down 5 and over 5, 10. Well, that's where we're going to cross. Down 5 over 5, 10. The reason why we didn't go into any other quadrants is because you can't have negative days or negative bikes or negative money in this situation because people are spending their money. So this is where our 2 points cross. So that point in terms of x and y, x is 20 and y is 5. So to answer the question, find the number of pairs of skates rented and the number of bicycles rented. Well, x represents skates, so there were 20 skates, and y represents bikes, and there were 5 bikes. So this is how many bikes and skates were rented in one day. Last here, this isn't really a problem that we have to solve, it's just a multiple choice question. So getting us ready for standardized tests. It says the Parks and Recreation Department in your town offers a season pass for $90. As a season pass holder, you pay $4 per session to use the town's tennis courts. Without that season pass, you have to pay $13 per session in order to use the tennis courts. So now it's asking which system of equations, or 2 equations, can be used to find the number x of sessions or of tennis after which the total cost, y, so y is the cost, with the season pass, including the cost of the pass. We're basically wanting to find out when are those 2 things the same as the total cost without using a pass. So we need to figure out after how many times doing this is it going to be the same as doing this. That's basically what they're asking. What's the solution? Where would these 2 lines cross if we were to graph them? So as a season pass holder, you pay $4 per session. You only pay this $90 if you have the season pass. So if you have that season pass, you're paying $90 plus $4 per session. So this doesn't even have that $90 factored in anywhere, so we know it can't be that one. So we have to have one that's $4 per session plus the 90. So I see that equation here, $90 plus 4 times per session, and I see that equation here. This one says $90 plus 13, which they're trying to combine the wrong one. This one is without the season pass. So we know it can't be B because this one, 90 plus 13, that's not correct. Without the season pass, you have to pay $13 per session. There is no one-time fee because you're just coming to use it every single time. So this one is just 13 times the number of times you're coming, x. So our answer would be C. This one looks correct because you have to pay the $90 plus 13 per session. But if you're not a member, you don't have to pay the membership fee, so that one part would not be included. So your answer would be C. If we wanted to, we could solve the linear system and figure out where those 2 would be crossing, but for now we are going to just move on because we just need to figure out, using the information that they gave us, which set of equations could we use. So your homework is a worksheet. So go ahead and show me your notes in order to get your worksheet. There is a front and a back side that you need to solve for y and graph. And reminder to enter your homework in your notes app and to make sure you're getting your homework done and turned in.